Globally, 43 million individuals endure the challenge of blindness and spatial immobility, while an additional 295 million grapple with substantial visual impairment. In California alone, there are 1 million blind Americans. Hi, I'm John, and these statistics highlight an undeniable problem: the overlooking of the numerous day-to-day struggles faced by millions worldwide with visual impairments. Our solution is to address and alleviate the struggles using a combination of hardware and software. To enhance the navigation experience for the visually impaired, we created a navigational suite and a complementary app with advanced object detection. We also added quality of life features to the app, such as an online bot therapist, to address associated mental health issues that come with visual impairment.
Jerry, and let's start with the suit first. To help a visually impaired person navigate, we have to do two things. First, we need to detect how close they are to the object, and two, notify the user of how close they are to the object. To achieve this, we place two sensors at the back, two at the front, and one at the bottom. We then coded these sensors in Arduino IDE with C so that when a person approaches any object in the 5-meter detection range of the sensors, corresponding vibrators near the sensor vibrate more frequently to warn the person that they are close to an object. To see whether the road ahead is blocked or not, the user simply has to check if there are no vibrations in the direction that they are facing or not. If there are no vibrations, the road is safe. And if there is vibration, the user simply has to turn to another direction and see if there are any vibrations to eventually find a safe path forward. We replace canes and guard dogs by providing a longer detection range of 5 meters and a more precise and immediate response. But that's not it. We have an app for even more precise detections, and an app that not only solves navigation struggles, but health struggles.
For the app, we use the most advanced libraries for deep learning models to build an adaptive app that can adjust to the current situation. The app itself is constructed using Flutter and Dart, which is a great combo that allows the app to be deployed on multiple platforms, making it accessible to all that need help. Powered in part by Google's machine learning library, the app's first feature involves constant object detection and notification for the user. When any object is seen within the camera view of the phone, it is announced with the text-to-speech tool, and the volume can be adjusted so it is not annoying.
Book. Person.
When a user puts their phone with the app open into a side pocket of the suit, both the app's feature and the suit's functionality complement each other wonderfully, as the wearer will be able to both receive information about how far they are from an object and also what the object is, spontaneously. We also addressed an often overlooked issue that comes with the visually impaired: mental illness. Some estimates put the percentage of blind people that acquire a form of mental illness as high as 44%. This is a serious issue that, if not dealt with, will lead to much more serious issues such as self-harm and even death. As such, we've implemented an online 24/7 robot therapy service powered by a large language model to help those that are in need of emotional support. An example can be seen here.
How are you feeling? There are lots of things you can do to cope with loneliness. Reach out to someone you trust, a family member, friend, or counselor, to talk.
Paired with the phone application functionalities that enhance the suite's capabilities, our solution is transformed into a truly accessible tool for the visually impaired. With features such as object detection, AI-powered therapist, and text-to-speech powered by high-end Google machine learning libraries, Second aims to bring the 5-meter spatial sensory world to the next generation of viability and widespread usage.